Well, thank you very much, and thank you for coming out on a warm night. I wish I could say it was sunny, but a little bit smoky. And I'm really excited to share with you some of the research I've been doing in the last few years. It's nice to see some familiar faces as well. Hi, John. And so today we'll be talking about Arctic marine mammals. And I wanted to start, so we've got a couple different, let's go back. Got a couple different things going here. I wanted to start the conversation tonight by setting the historical context and seasonality within which Arctic marine mammals live. And so there are certain environments, like the poles, that impose extreme seasonality for marine species. And so if we take a trip today, or tonight, to the Arctic and the US Arctic, the Chukchi and Beaufort Seas, you'll see that there's historically a huge amount of the area that was historically covered by dense pack ice, particularly in the winter. And so Arctic marine mammals are specially adapted to ice and snow regimes and the habitat in which they occur. And so this has historically been dominated by this very seasonal environment and dominated by the annual sea ice cycle. And so I'll just play this animation to give a sense of how sea ice extent traditionally was at its lowest extent in the fall in September. It grows to its annual maximum extent, typically in March, and then recedes again to its open water season during the summer and the lowest extent during the fall. So what we're now seeing is that sea ice cover has rapidly declined. And so that's highlighted in this animation, again, showing the Arctic annual sea ice minimum, which typically occurs in September, and that's detected from satellites since 1979. And so September's sea ice cover on the Pan-Arctic scale has declined at nearly 13% per decade over this period, 1979 through 2018 in this animation. So what that means for Arctic marine ecosystems is that they are also in rapid transition, and particularly in terms of this Arctic sea ice cover, as well as there's declines in sea ice thickness, there's declines, or there's changes in the duration of that seasonal sea ice cover as well. So sea ice is breaking up earlier in the spring and freezing later in the fall, which means there's overall an increased duration of that open water season during the summer. Okay, and so now if we look down at the top of the globe, this is just one more representation. This is from this past September in 2018, where you can see the white is the extent of sea ice in September 2018 relative to that orangey pink line, which is the median ice extent from a previous period, 1981 through 2010. So what I want you to see here is, we'll be talking a lot about the Alaskan Arctic today, but on a pan-Arctic basis, there's a lot of variability in the areas that have lost the most ice. And in particular, the north of Alaska, the Chukchi and Beaufort Seas, are two areas where there's been particularly pronounced sea ice loss. And so that sea ice is, of course, incredibly important for Arctic marine ecosystems because it's, as I've said, the dominant physical structure that's affecting all of the localized lower level productivity during the short summer season. And so what's happening as that ice recedes, did the mic just turned on a little bit there? So as ice retreats in the spring, you start getting increased solar radiation. You get a big bloom of phytoplankton. That's the plant productivity that drives and fuels this whole marine ecosystem. It's a relatively short food chain. So from that phytoplankton, it goes to the zooplankton, which are then eaten by fish and consumers, as well as then the upper trophic level consumers and predators like marine mammals. And so, let's introduce our cast of characters for tonight. So we have 7 endemic Arctic marine mammals, and by endemic I mean they're found nowhere else on the Earth, and they are considered sentinel species, they're ice adapted, they're very culturally and ecologically critical to these Arctic marine ecosystems. And so when we think about what the impacts of sea ice loss will be on these species, it's been challenging because we're actually limited by they're data limited species. So there's relatively limited baseline information to make the analyses and detect what changes mean for these species. And so the assumption has typically been based on what we know about their ice associations. And so the pinnipeds, the ringed seals and bearded seals and walruses, as well as polar bears, are what's considered ice obligate. So they use sea ice as a platform. And that is critical for life history functions like foraging and reproduction and resting. We also have the cetacean species, the whale species, so beluga whales and bowhead whales and narwhals, and these are more considered ice-associated, so they don't use sea ice as directly as we see with those other species, those other 4 species. And for all of these species, sea ice then plays this indirect role that affects foraging, like I just spoke of a few slides ago, where the sea ice is affecting localized productivity, and that then will fuel the food chain and affect foraging opportunities. It also affects access. These are migratory species that move in and out of the high Arctic as sea ice retreats in the spring and then advances in the fall. And so they are accessing these high Arctic regions for foraging. And so with changes in the duration of sea ice cover and the increase in the open water season, that's also affecting their access to some of these foraging areas. Of course, layered on top of some of the uncertainty we have about these species, we also have some uncertainties about human activities and development interests that are also changing in these regions. And those have the potential for impacting marine mammals as well. So these are 2 maps that provide examples of projected vessel tracks through a recent period on the left and then a future period on the right. And so the blue lines are potential tracks for vessels that are open water class vessels, whereas the red are from polar class vessels. So those are ice strengthened vessels. And so this is showing in the recent period that both types of vessels could be moving through the northern sea route, which is north of Russia. And then in the future projected period, there's projections that both classes of vessels would also move through the Northwest Passage north of Canada. And that polar class vessels, those ice strengthened vessels, could actually move right over the North Pole within a matter of decades. And so today we're going to dive into these topics of trying to assess how Arctic marine mammals are responding to sea ice loss. And in particular, I'm going to talk in the first section about beluga whales, and so using beluga whales in the Alaskan Arctic as sort of a case study or an example of how some of the Alaskan marine mammals are actually responding. And then we'll switch into talking about this emerging risk of vessels in the Arctic and how they are increasingly able to access areas that were previously unavailable to vessels, and what that might mean for Arctic marine mammals. And then we'll finish with a brief discussion of what my sort of conjecture or my ideas of what this might all mean for future resilience of Arctic marine mammals. Okay, so for beluga whales, these are pan-Arctic marine predators. They are ice-associated, as we mentioned a few slides ago. They're long-lived. They have a lifespan similar to humans. They have this wide, discontinuous Arctic and subarctic range so they're distributed in approximately 20 populations across the Arctic, as you can see in this map. And the darker shading corresponds to areas used during the summer. So they have this characteristic where they exhibit summer philopatry. What that means is that they return to the same areas year after year, particularly in the summer, and they're following migration paths that they've learned from family members. So that's a brief introduction to beluga whales, and we'll be specifically talking about these 2 populations, the Chukchi Sea population and the Beaufort Sea belugas. And so the general paradigm has been they spend their winters in the northern Bering Sea and then migrate north and to the east in the spring as sea ice retreats. They go to these sort of generalized summer distributions that are shown in purple and green here before migrating back to the west and south in the fall as ice advances, so as ice freezes up again. And so my work has been, I've been really fortunate to address some questions about changes in habitat use and movements and underwater behavior using satellite tagging data. And so this is work that has been done in collaboration with coastal communities in northern Alaska and in Canada as well, and particularly led by my collaborators at the North Slope Burrow, so Robert Sudam at the North Slope Burrow, as well as Pierre Richard at Fisheries and Oceans Canada. And so we work with communities to get access to these beluga whales, and then we attach a satellite-linked tag to the dorsal ridge or to the back of these beluga whales. The whale is then released again. And when the animal comes to the surface, the tag turns on and transmits information about their locations and diving behavior to a polar orbiting satellite. And then those data get relayed back to us electronically. And so it's been this really nice system to get relatively long-term movement and habitat use information from individual whales of each population. And these are whales that spend most of their time offshore, obviously in pretty remote and challenging areas that are hard to get to. And so it's been a really nice little system. And so this animation is just giving you an idea of the daily locations of whales tagged across several years from both of these populations. It gives you a sense of their broad movements through both the Chukchi and Beaufort seas. As I mentioned, these are ice-affiliated populations of whales, so they migrate into these high Arctic regions to feed during the productive summer. And so my research has really looked at changes in the cover and timing of sea ice and how that could impact these populations of belugas. So these whales have been tagged since the 1990s, and I think, so this gives you a little bit more details about our tagging. So these are daily locations from July through November of both populations of tagged belugas. So again, the Chukchi belugas in purple and the Beaufort belugas in green. And each dot is a daily location whereas the shaded regions correspond to home ranges and core areas. So those are areas that are primarily used, and that's specifically for the summer season, July and August. So whales are generally tagged in early July, and the tags can last anywhere from a few weeks to 18 months was the longest tag duration for this data set. And in total, over 60 whales have been tagged between the two populations between 1993 and 2012. So these data are really forming the basis of my ability to examine some of the population-specific responses to changing sea ice conditions in the northern Alaskan Arctic. And so today I'm going to focus briefly on these two themes to address this question of shifting beluga habitat, behavior, and migration. And so it goes back to this idea of how does sea ice affect cetaceans or whales? And so sea ice structures the habitat, and we'll look at whether habitat use has changed through time, and in particular foraging behavior as well. We'll also look at whether sea ice is affecting their access to their preferred summer habitat in the high Arctic. So by looking specifically at migration timing and how migration timing may have changed in association with later freeze up of these regions by sea ice in the fall. And so, I wanted to acknowledge that this work has definitely not been done in isolation. There were several collaborators at the University of Washington who worked with me on these data sets and these questions, as well as I mentioned, Robert Sudam and Pierre Richard from North Slope Burrow and Fisheries and Oceans Canada. Okay, so hopefully these animations will play. I'm going to play you two animations that were put together by my collaborator, Harry Stern, at the University of Washington. And so what these different colors correspond to are different sea ice concentrations, where the reds correspond to really dense sea ice, over 90% sea ice concentration. The different shading corresponds to the bathymetry, the water depth in the region. So this is the relatively shallow Chukchi Sea, the narrow continental slope of the Beaufort Sea, and into the very deep Canada Basin. You're going to see the date is going to cycle through on the bottom right, and the shapes correspond to those home ranges, those areas most frequently used by the belugas, by each population, and that's going to change each month. And so we're going to look specifically at some tagged belugas from the Chukchi population, and this is from the year 2001. And so let's see if we can get this to play. So here are our tagged belugas. This is now into August, and you can see they've moved into the Beaufort Sea. It's September. There's a lot of ice still in the Beaufort Sea. They're moving out in October and south through the Chukchi Sea and through Bering Strait. They move through the Bering Strait by early November, late October. Okay, so now for comparison, let's look at 2012. So 2012 was the lowest sea ice extent on record for that fall. And we had one female Chukchi beluga whale tagged that year. And so I want you to kind of just get a sense of how different it was for that year versus a decade earlier in 2001. So here's our tagged whale. We're into August, and you can see that the Beaufort Sea is completely free of ice. She's moving into Canada Basin. It's September. Now we're in October. She's still in the Beaufort Sea. And by mid-November, she gets moved into the Chukchi Sea and moved out relatively rapidly by late November. So quite a bit later than those whales in 2001. And so this animation, this tag lasted longer, so the animation goes a little bit longer. We start to pick up her northward migration into April here before the tag fails. So I think there's two key things to take from those animations. One is that this is a really dynamic environment. A dynamic seascape is the word that I like to use. And so these whales are mammals. They've come to the surface to breathe, and so they are moving around in this really dynamic environment. And you can see that even at this pretty coarse scale from the satellite-derived sea ice data here. But then the other important thing is obviously the conditions that those whales experienced in 2001 were quite a bit different than what we saw for that whale in 2012. And so there was this rapid decline of the sea ice and retreat of the sea ice in the Beaufort Sea in particular, and the later freeze up in the fall as well. Okay, so then to start establishing what some of the responses by these whales might be, one of the first steps is to just ask the question of what environmental factors affect their habitat use. And so to address this, I built some habitat models that are called resource selection functions or resource selection models. And I'm not going to go into all the nitty-gritty details here, but this is an example. This map is an example of the predicted habitat for one of those groups, the Beaufort females, the Beaufort belugas, and the females in July. And so you can see the darker shading corresponds to the highest probability of use for that time period for those whales. And so one of the things that we found that was really important when we built these models is that timing matters. So again, this is a really seasonal environment. These are migratory animals, and the important habitat predictors that came up as predicting the habitat for these whales really changed every month. So month to month through the summer and fall season, habitat predictors varied quite a bit. But one of the interesting things was that sea ice was just one of the primary predictors, but not actually the most important one when it came to habitat selection for both of these populations and throughout each of the months that we looked at. And it was really some of the oceanographic features that we think affect prey and the distribution of their prey, things like the proximity to hotspots and water depth, which were actually stronger predictors of habitat use than sea ice cover. And so, it begs the question of what really is the importance of some of that sea ice and the sea ice loss, at least when it comes to habitat use for these whales. And so to kind of keep digging into that question, we then considered whether beluga habitat use changed through time. And to do that, we looked at changes in resource selection. So we modeled that from 1990 through 2014. So we took that on a year-to-year basis. And then when we get these maps, you can then identify the areas that are the most likely to be used. And we can find out what was the amount of what we called optimal habitat in each of those years, 1990 through 2014. And then we could look and see if there was an increase or a decrease in the amount of that optimal habitat through time. And so just jumping right into some of those results, we found really very few cases where there are any significant changes in the habitat selection using sea ice as a predictor, particularly when we compared 1990s to the 2000s. But you can just see that on a map here as well. So we also saw very few shifts in the spatial distribution, so where predicted habitat occurred. And so these are just averaged predicted habitat, in this case for Chukchi males in the month of July for the 1990s, the 2000s, and the 2010s. And so, there might be slight variations in the intensity of use of one of those pixels, but in general, those maps all look pretty similar, right? So we didn't see a lot of predicted shifts in habitat use. When we pulled out the amount of the optimal habitat, like I was speaking of a few minutes ago, we also didn't see any obvious cases of increases or decreases in the amount of optimal habitat for either population and in any of the different months. And so in this case, it suggests a pretty limited effect of sea ice declines on the habitat use of these beluga whales. And so what we've kind of concluded from that work is that despite sea ice loss, belugas are returning to the same areas year after year, right? They have that site fidelity, and they can flexibly respond to some of these dynamic changes, at least in terms of the sea ice cover at the surface. And so perhaps it's actually some of the subsurface oceanographic conditions that are presumably affecting their prey that are most likely more important for their habitat selection, or that's what our models suggested. And so the next step was to ask whether there were any other indirect effects of changing sea ice habitat on their foraging behavior, given that there could be indirect effects of changing sea ice on the food web structure. And so to look at that question, we also looked at diving behavior as an indicator of foraging behavior. So let's just take a second, though, to more closely look at some of the changes that have been occurring in the Arctic seasonal ice zones, and in particularly in the Pacific Arctic. So there's been an increase in the open water season. That's related to increased summer storm activity. There's more wind forcing, and that's all increased. There's also increased heat in the Pacific Arctic and more freshwater input. And so what that suggests is that there's been more, what the oceanographers are telling me is that there's more vertical mixing as well as upwelling in this region. And so that has led actually to an increased prevalence of a secondary phytoplankton bloom. So if you remember back to the beginning, when the sea ice is retreating earlier, now this open water season is so long and there's more mixing of the nutrients that we're actually getting a secondary phytoplankton bloom, which then also seems to be affecting some of the zooplankton. So we're getting more advection, so movement of zooplankton from lower latitudes moving into this region, and with the increased productivity, it seems there's also increased zooplankton, which are the prey for Arctic cod, which are the prey for beluga whales. Okay, and so while we don't really have the data to examine shifts in fish or other potential prey in terms of their distribution or abundance or timing, that's just not data that are available. We can compare diving behavior of the Chukchi beluga population in particular across the years that we had them tagged. So we can consider whether there have been detectable changes in their diving behavior as a reflection of potential changes in foraging opportunities. And I'll note that we only had data available to look at this for one of the populations, the Chukchi populations. So we compared a number of different diving metrics from the 1990s to the 2000s. And so we found that in general, the Chukchi belugas are spending more time at depth in the recent years. And so this is just one example where on the y-axis here, we're looking at the number of dives that are long duration dives. In the blues for the 2000s versus the reds, the 1990s. And that's looking across the summer to fall period. So that was one indicator of changes. We also saw fewer short duration dives, fewer dives to shallow depths, and on average, deeper dives by these Chukchi belugas in the 2000s compared to the 1990s. And so we think that this corresponds to some of these regional oceanographic shifts in what are the productive depths at which these belugas will be foraging. Okay, so what we found is that the loss of sea ice cover didn't necessarily affect habitat selection, but we think there's some indirect behavioral effects that we assume are related to foraging. And that goes to that first theme of sea ice is structuring the habitat that these belugas are using. We also wanted to look at whether sea ice is affecting their access to preferred habitat. And again, we're going to now shift gears a little bit and look at migration timing in the fall and how that may or may not have shifted in response to this later sea ice freeze-up. And so to ask that, we looked at a recent data set for freeze-up timing by some of my collaborators, Kristen Lydra and others, where they looked on a pan-Arctic basis at the timing of the open water season across all of these different regions. And so what we did is we went to the Bering, Chukchi, and Beaufort Sea regions and pulled out the time series for when fall sea ice freeze-up occurred, which is on the y-axis for each of these two graphs. And you can see that for both the Chukchi Sea and the Beaufort Sea, over the period of the satellite data coverage from 1979 through, I think this is through 2014, there were significant delays or later, sea ice froze up later by nearly a week later per decade for both of these regions. And so then to look at the beluga migration timing relative to that fall freeze-up timing, we looked at what we called passage points. So these are the latitudes and longitudes that belugas will pass on their westward and southward migrations in the fall. And so today I'm just going to show you an example from one of those in the interest of time. So we're going to look at the date at which these two populations of belugas moved south of 70 degrees north each fall. And so first, let's look at the Beaufort beluga population. And the first day these whales were moving south of 70 degrees north was actually not different between the two periods, the 1990s versus the 2000s. But then when we looked at what the date of their migration south relative to the date at which freeze-up occurred in the Beaufort Sea, the Chukchi Sea, and the Bering Sea, we also saw no correlation. So it seems like there was not a relationship with freeze-up timing for the Beaufort Sea belugas. In contrast, for the Chukchi belugas, we found that the first day they migrated south of 70 degrees north was nearly 3 weeks or over 3 weeks different later in the 2000s compared to the 1990s. And that was strongly correlated with the timing of freeze-up in the Beaufort Sea, the Chukchi Sea, and also the Bering Sea. And so what we saw here is that migration timing appears to have shifted for the Chukchi belugas in response to this later freeze-up timing in the fall, but we didn't see that same response for the Beaufort belugas. And so I think there's a couple of interesting things that are at play there. So first, I want to emphasize there were distinct responses by these two populations that actually use a lot of the same areas. They're sympatric populations, and they had very different responses. But then also, the responses that we saw for the Chukchi belugas occurred over a relatively short timescale. That was on a decadal timescale. And so I guess we can't, right. So I think some of the important conclusions here of the beluga whale research is that these beluga populations are balancing socially maintained, heritable distribution patterns and migrations with some plasticity on decadal timescales. And so to put that in a little bit more general language, I think these belugas have really persistent distribution and habitat use patterns despite the fact that their sea ice environment has changed at the surface. But there were also some distinct responses among the two populations. And the Chukchi population in particular displayed shifts in their fall migration timing as well as their diving behavior, which were correlated with these changes in the sea ice environment. And so the next question, though, is that I can't really say whether these changes or responses or non-responses are necessarily positive or negative for the populations. And so the results for the Chukchi belugas in terms of staying longer in the fall in an area that's a productive foraging area and changing their diving behavior, it could be a response to improved foraging conditions in recent years. It could be a good time to be a beluga, which is similar to what we're hearing in some cases for bowhead whales in this region, where bowhead whales in recent years have better body condition, their population numbers are increasing, presumably because of things like improved prey conditions. On the other hand, we don't know if Chukchi belugas are just making the best of a bad situation. So for deeper and longer dives in particular, that's really energetically costly behavior. And so a persistent trend for those deeper, longer dives could have negative implications for the populations. Similarly, if they're staying longer in the high Arctic in the fall, they could be exposed to more variable freeze-up conditions, and so they might run a higher risk of entrapment in the sea ice. And so I think looking forward, at least for these populations, it would be really useful to have additional monitoring on these characteristics and these responses, but also to start looking at some other metrics, things like body condition, that might help us understand population level implications of responding or not to some of these changing conditions. And then I'll just emphasize again that we had these two populations that are just adjacent to each other, and they didn't respond the same to some very similar conditions. And so not all populations across the Arctic are going to respond the same. As I mentioned, there's about 20 populations of belugas, and so we can't say that what happened for Chukchi belugas will happen elsewhere necessarily. Okay, so now let's switch gears a little bit, and I will talk a little bit about some recent research where we've examined some of the new risks or emerging risks for these Arctic marine mammal species, and we're going to look now on a pan-Arctic basis. And in particular, talk about a recent vulnerability assessment of Arctic marine mammals, so all 7 of these species, and in fact 80 submarine populations of them, to increasing or the potential increase in vessel traffics in the 2 Arctic sea routes, the Northwest Passage and the Northern Sea Route. And this is work that's been done with my collaborators, Kristen Lydra and Harry Stern at the University of Washington. So I think that you've probably gotten the picture that, no longer are we talking about an Arctic that was experienced by some of the earliest European explorers. And so this is Amundsen, who was the first to traverse the fabled Northwest Passage. It took him 3 years. He overwintered, and that was over a century ago aboard a 60-foot wooden sailing ship. Now, if we fast forward to 2016, we had the first large cruise ship, which was over 800 feet. It carried over 1,500 passengers, and it completed the Northwest Passage in a matter of weeks. This past year, we also saw ground-breaking transits of the Russia's Northern Sea Route by a 200-meter container ship. And so there's a little bit of online data about full vessel transits of these 2 sea routes from a period 2011 through 2016, and you can see that more than twice as many vessels transited the Northern Sea Route during this recent period than the Northwest Passage. All of those were relatively large ships, over 20 meters in length, in comparison to the Northwest Passage, where the majority of vessels were relatively small, and in fact, those were largely private vessels. And so some of the concerns about the expansion of large vessels in the Arctic sea routes are based on a large body of research at lower latitudes, where we're seeing that there can be negative implications of vessels in some of the shipping vessels in some of the marine mammal regions. But an additional factor, I think, for the Arctic marine mammals is that this also represents a really novel risk factor. As I mentioned, these are endemic species. They really just have never been exposed to large amounts of large ships in the past. And so some of the concerns, one of the concerns is related to the fact that marine mammals use sound. They use sound for foraging, communication, and navigation. And so there are concerns about acoustic disturbance by the sounds made by vessels. There are also concerns about death or mortality or injury resulting from collisions with large vessels. So this is a picture of a North Atlantic right whale. And right whales are one of the bowhead whale's closest living relatives, so that's certainly a concern of large ships using this region. There's also the potential for shifts in behavior or habitat displacement that's been raised as a concern for, and this is a case for beluga whales in the St. Lawrence Seaway in Canada. And so we have been looking at vulnerability basically on a comprehensive scale, looking across all of these 7 species and all 80 submarine populations of them. And what we're trying to do is measure the risk of each of these populations to vessel impacts. And that is measured as a combined effect of what we're calling exposure and sensitivity. And so just to walk you through what we mean by exposure and sensitivity, so First, exposure was measured on a population-specific basis, where we used the literature to delineate September ranges for each of these populations. And so we focused on the month of September because, as you might recall, that's the time period when sea ice extent is at its minimum across the Arctic. And so we expect that will be the period, at least initially, where vessels will start to increase the most, or it provides the easiest access for vessels. So to give you an example from polar bears, there are 19 subpopulations of polar bears across the Arctic. And this is we delineated the ranges for each of those 19 populations for September. We overlaid the sea routes, the Northwest Passage and the Northern Sea Route, and then we could translate that into a score for exposure. So the proportion of their September range that overlapped with one of those sea routes resulted in a score of between 1 and 3. When we looked at sensitivity, which was the second component of our vulnerability analysis, that accounts for the potential consequences of being exposed. And so there were 7 different variables that we considered for each population. And again, this was largely based on the literature. We reviewed hundreds of different sources for each of these different species and populations and scored each of these characteristics from 1 to 3. And so just to give you an example, in this case, this is from the Beaufort Sea belugas that we talked about earlier, where you can see that there were scores for the vessel effects that I mentioned, how frequently each population was exposed in the recent years, and then a converted score based on a previous study that was estimating the susceptibility of each of these species to sea ice loss. And then we also looked at each population's relative abundance and their population status from recent assessments. So altogether, we could then get an average of their sensitivity score that ranged from 1 to 3 that went into our vulnerability assessment. Okay, so moving right into some of those results, 53% of those Arctic marine mammal populations were exposed to either the Northwest Passage or the Northern Sea Route. And so this figure is meant to show how sensitivity by exposure yielded vulnerability. So the vulnerability is the color map in the back. And the different symbols correspond to each species, so the different shapes correspond to each species, and each dot is one of the populations that was exposed. And I think it's interesting to point out here that there was a lot more variability among these populations in terms of their exposure score than their sensitivity. So most of these species are relatively sensitive, but they vary quite a bit in how exposed they were to the sea routes. If we categorize these 42 populations that were exposed into the different species, you can see that the cetacean populations, those whale populations on the left-hand side, tended to have higher vulnerability scores than particularly the ringed seals and the bearded seals and the polar bears, although walruses also had relatively high vulnerability scores. And when we averaged across all of the populations for each species on a pan-Arctic basis, we found that narwhals had the greatest vulnerability scores. And that's a result of primarily their high exposure. So narwhals have a relatively restricted range, and during the month of September, most of those populations of narwhals are actually smack dab in the middle of the Northwest Passage. So really high exposure, as well as several characteristics that also made them sensitive. But maybe some of you would be surprised to see that polar bears actually had the lowest vulnerability scores. And so that's, again, primarily because of their relatively low exposure. So looking in the month of September, polar bears are often on land, or else they've moved north with the retreating sea ice edge. And so they just weren't exposed to the same degree as some of these other species and populations. And then similarly, polar bears have some characteristics that also made them less sensitive. So polar bears are an exception. They don't use sound to the same degree that other marine mammals do. So that was one characteristic that made them less sensitive. Okay, so we also mapped maximum vulnerability across the Arctic, and as well as by the different taxa. And so again, the theme here is that there's variability among species, but also among regions. And so there were certain areas like the Bering Strait and Lancaster Sound and in northern Canada, which were characterized by populations that had 2 to 3 times higher vulnerability than some of the more remote regions of the Arctic. And maybe that's not that surprising because these are obligate pathways for the vessels that are going to be moving in and out of these sea routes, but also for hundreds to thousands of migratory marine mammals that move through these regions on a seasonal basis. We also looked at uncertainty. And so uncertainty scores took into consideration how much information we had available, so how much literature was available to delineate the September ranges that were used for exposure scores, but then also several aspects of the sensitivity to vessels and their population demographics. So when we mapped out uncertainty, you can again see that there's variation among the different regions of where was the most uncertainty. So for example, the Russian Arctic particularly stands out as generally high uncertainty. But you might also notice that there was variability among the species. So the cetaceans, those whale species, actually had lower uncertainty than the pinnipeds, the seals and walruses, and the polar bears. And so overall, what I would say is that Arctic marine mammals are pretty data limited, but some species like ringed seals, such as in this picture, or bearded seals, still had greater uncertainty. And so some of the data gaps for these species include things like relatively poor distribution information across the Arctic, which was important for estimating their exposure. And then most of these populations also lack information on their population trends or status. And there are relatively few studies that look at what are vessel effects to get at sensitivity for seal species relative to an emerging body of research that's being done for bowhead whales, beluga whales, and narwhals. Okay, so in conclusion of this section, I think the analysis, or this vulnerability analysis, is really meant to provide a comprehensive assessment that I just see as one of the first steps in understanding the heterogeneity of risk to vessels in an Arctic that is and will be increasingly navigable. And so I'm hopeful that some of this analysis can be useful for developing guidelines that can be used for best practices as maritime industries are really poised to advance into this region. But I think there's still a lot to do. In particular, I think that our work has identified areas and species where we really need some detailed case studies, and that will be informative moving forward. Similarly, our work focused on these two sea routes because that was tractable on this Pan-Arctic basis. But what that meant is that we left out certain locations like northern Norway and Svalbard, and certain seasons like the spring, where we might see some very different answers in terms of which species or populations are most vulnerable. I would also say one of the things that we were really challenged by was actually finding and obtaining recent and openly accessible data on the numbers of vessels, the types of vessels, and where those vessels are. And I think that's a really critical need. And there are places where there's some existing data, like in this Bering Strait region. But for doing more detailed research and understanding what some of these effects are, that's a pretty important thing of knowing where the vessels are and how many and what kinds. And then lastly, I'll just end this section by noting that we have the opportunity for more proactive management as we sort of look at this new risk factor, and we can learn from some of the monitoring and the guidelines, the vessel management guidelines that have been used at lower latitudes. Recently, there were some voluntary routing guidelines proposed or that are now in effect for the Bering Sea, and we can start monitoring how effective they are moving forward and thinking about elsewhere in the Arctic as well. Okay, so now we've talked a little bit about some of the somewhat flexible and diverse responses that we saw in terms of habitat and behavior and migrations for beluga whales in Alaska. We've talked about some of the vulnerability of Arctic marine mammals to these emerging risk factors, and now I'm just going to wrap up with a bit of discussion on the current state of sea ice loss and marine mammal responses, and how all of those things converge in terms of the future resilience of Arctic marine mammals. Okay, so earlier I gave that case study for whales and that are ice associated. So they primarily use sea ice in an indirect way. But I wanted to make a couple of notes about species that also rely on sea ice and snow cover for reproduction, resting, and molting. And so that's work, I'm going to leverage some of the work that's been done by several of my colleagues, some of them actually in this room. So I think that our results with belugas are somewhat similar to some of the emerging trends we're seeing for even some of the ice obligate species, like ring seals. So again, this is a picture of a male ring seal from Kotzebue Sound last spring. And ring seals are an incredibly abundant species, and they rely on sea ice platforms for reproduction. And so some of the work that's been done in the Canadian Beaufort Sea suggests that some of the ring seal populations, their body condition has declined in recent years. But in contrast, in Western Alaska, some of the work by folks at the Alaska Department of Fish and Game here in Fairbanks, they've really created this long-term biological sampling program in Western Alaska, and they've identified different trends. So for example, this is a figure that shows the proportion of pups is higher in the 2000s than several of the previous decades. They've also seen trends of improved blubber thickness, which is a measure of body condition. So that's higher in recent years. We're also seeing new results suggesting higher pregnancy rates and a younger age of maturity. That said, I think it's also important to recognize that we don't know about long-term viability of pups for these ring seals. And so ring seals in particular create winter dens where they give birth to their pups, and then they rear their pups, they give birth in the spring and then rear their pups in these dens, these lairs. And it's been unclear, I think, how some of these unprecedentedly low sea ice years, particularly last year and this spring in the Bering Sea and in the southern Chukchi Sea, and incredibly early breakup periods will really affect pup viability. So this is a photo of a melted out lair in Kotzebue Sound, the spring that I took on the sea ice in Kotzebue Sound. There was a pup associated with this lair, and then within a matter of just a couple of weeks later, this was actually open water. And so that was probably at a time when the pup most likely would not have weaned from its mother. And we've been starting to see lots of reports this spring and the summer of dead pups from ring seals, bearded seals, and spotted seals, as well as walruses. So there could be some correlations with some of these environmental changes. And I think one of the really important things we need to start getting that's hard but would be useful to understand is some of the viability of the pups moving forward. Okay, so polar bears, I think, are another interesting example. There are 19 distinct subpopulations, as I mentioned earlier, across the Arctic. And while I think we hear a lot about polar bears and Arctic climate change, not all of them are necessarily being recognized as negatively impacted. So in some cases, we have adjacent populations that have different responses again. So this is a figure put together by USGS and US Fish and Wildlife Service researchers showing an increased size at age for Chukchi Sea polar bears. I think you kind of don't need the graph because you can just look at this picture. This is a really fat bear. And so there's also reports that suggest cub production is great, survival estimates are great for that Chukchi population, but the adjacent southern Beaufort Sea population is not seeing, there are signs that they're not doing as well. Cub production is down, and they're not as fat as these types of bears. So I think ultimately what I want to get across here is that the responses, the risks, and ultimately the future resilience of these Arctic marine mammals varies a lot. It varies among regions, it varies among populations, it varies among species. And I think it's important to emphasize this diversity of responses. We think about some of these species as the iconic losers when we talk about Arctic climate change, but I actually think it's a much more nuanced picture. And perhaps we should restructure the argument and consider a story about variability. And so the current picture from my perspective in the Pacific Arctic is that marine mammal responses can be diverse, they can be flexible, sometimes they might even be positive, at least in the short term. And so We know the Arctic is locked into some continued sea ice loss without major climate change mitigation. We know there are a number of emerging risks for Arctic marine mammals, and so I think moving forward, we need to stretch beyond assumptions of how these animals are associated with sea ice and instead examine the spectrum of responses and more broadly consider resiliency. And we can think about resiliency through variations in population ecology and health. So this is just a diagram or a roadmap from some of my colleagues, Sue Moore and Randy Reeves, where they suggested examining resiliency by looking at some of the variables that I explored today, but also some additional factors that will play into our understanding of predicting resiliency for each of these Arctic marine mammal populations into the future. Admittedly, part of the problem is that there's still a lot of basic ecology we really just don't know about these populations and species. So each of these boxes represents one of the Arctic marine mammal populations. And so in green are populations that we know are increasing, yellow are those that are stable, and red are declining populations. But you can see that the vast majority of these populations are data deficient and have unknown status. So I think ultimately one of the major needs right now is actually much more monitoring and perhaps emphases on new partnerships. And so I'll just end with this last slide here. I think that one of the paths forward really involves bridging our Western or conventional science with local indigenous communities. They rely on Arctic marine mammals, and they are among the first responders to Arctic change. When we think about questions of animal responses to change and emerging risks, these are also at the core of food security questions at the coastal community scale. And so one of the things that I'm increasingly trying to do with my research is to create partnerships where we can weave knowledge systems and lead that I think are leading to new insights and opportunities. This is a figure from a recent paper from Sue Moore and I, where we presented an example of opportunities to bridge these Western science and indigenous knowledge systems. And so things like expanding community-based observing partnerships to encompass measures of marine mammal health and distribution and behavior might in turn also improve our understanding of the impacts of these shifting conditions on these species that are really critical to the ecosystem, but are also critical to the indigenous way of life in northern Alaska. So that's definitely something that I'm hoping to continue pursuing through collaborative research moving forward. Okay, so I just wanted to take a second to acknowledge a number of different funding sources and collaborators and support for all of the research I've presented today. I'm particularly funded through a community-based observing program called the Alaska Arctic Observatory and Knowledge Hub. Some of my research is also funded by the Gordon and Betty Moore Foundation. That vulnerability analysis was funded by NASA, and then there was a huge number of people that were involved in tagging and funding the beluga whale research that I talked about at the beginning of the talk. With that, I thank you very much, and I'd be happy to take some questions.
Recently, there's been some news coverage about people finding a lot of dead seals on the coast, and I was wondering if you could comment about that.
Yeah, so I think ultimately we don't know what is causing a lot of that problem right now. As I mentioned, this past year and the year before also, in 2018 and 2019, sea ice coverage in the Bering Sea and the Chukchi Sea in western Alaska was at unprecedentedly low levels, and sea ice broke up incredibly early. Most of those seals, as I understand it, are primarily pups, and that they are also often emaciated or thin. And so that suggests to me that they're, so with these pups, as I mentioned in at least Kotzebue Sound, where we were seeing areas that we knew were pupping areas, and they had pups that couldn't have been weaned when that sea ice broke up. the likelihood that those pups would survive is probably pretty low, depending. And there's some variation in that. Pupping occurs over a long period of time. So that's one. That's my personal firsthand experience and my thought. But again, I will say that I think there's a lot of unknowns there. There was an unusual mortality event for a lot of the ice seals in 2011 in Alaska, which there was an illness that was never, the cause of that unusual mortality event was never determined. And so there's continued concerns of illness and disease and unhealthy seals in Western Alaska. So you're right, there are a lot of dead seals popping up this spring, and there are a lot of people that are thinking about and wondering about that question.
A couple of years ago, I saw a program that was talking about predation by orcas, and they had come into, as I recall, the eastern Canadian Arctic. Did you observe anything like that on the western side?
Yeah, so killer whales in the Arctic, that's a question that always comes up in the, so thank you. So that's right, in the eastern Canadian Arctic, there have been an increase in the sightings of killer whales, and it seems that they are largely mammal-eating killer whales, so not all killer whales eat mammals. And so they seem to be focused on beluga whales and narwhals and perhaps bowhead calves and ice seals as well. I haven't necessarily seen that that's been the case in the Alaskan Arctic as well, although we do see bowhead whales and belugas and other species with signs of killer whale predation. But we are also monitoring them a lot better right now too. So there are aerial surveys in the Chukchi Sea and the Beaufort Sea now more than there ever was. And so we are seeing more killer whales through those sorts of observations, but we're monitoring them more now too. So from my opinion, I think that there's still work to be done, and that question is unanswered. I think others might disagree with me on that, but yeah. So, but it is, it continues to be a concern for Arctic marine mammals, this potential for new predation or, a novel predation source. I think killer whales have always fed on all of these species. Perhaps their access is better now. So you have a killer whale with a dorsal fin the size of a barn door. They are just not as maneuverable in sea ice. They are not adapted to move through sea ice environments. And so now with less ice, it does lend to the idea that they have greater access and ability to move into these regions. Yeah.
The initial portion that you dealt with the belugas was very interesting. Do you think statistically you were sound in what you were generalizing about? Because I don't know what the total population is relative to what you sampled.
Right, so we do have to make some assumptions that our tagged whales are representative of the greater population. And so, when you think about 60 tagged whales between these two populations, of populations that are 20,000 and 35,000, is perhaps a bold assumption. And yet at the same time, these are whales that do the same thing year after year. They have this site fidelity, and that's actually one of the ways that we distinguish these two populations. They're also genetically distinct. And so yeah, I think that it held up quite well to peer review and that sort of thing, but it's a good acknowledgement or assumption to acknowledge that we are assuming that the whales that we are tagging are representative of the population as a whole. Does that get at your question? Okay.
So you said there were 60 whales tagged. Is that over the whole study or each year?
That's over the whole study. So I don't know if you guys can imagine, but basically when we go to tag these whales, and there are others in this room who've done this as well, where you work with the community to get access to beluga whales, and you may or may not tag a whale in a given year, and if you do tag a whale, that tag may not continue to function. And so it's a big endeavor, and I think that I've been in a really unique and fortunate spot to have access to a database that has gone on for so long. That's like one of the largest sample sizes for any whale tagging in the world, and certainly for an Arctic species that is hard to get access to, that's pretty unique. Yeah.
Is there any information or does data exist to look at things as correlates like water quality, water acidity, the amount of phytoplankton, numbers of prey species?
Yeah, so those are all, exactly, that's right. And I didn't go into all the details of all of the environmental characteristics that we looked at. But I will say that one of the challenges working in these regions is that a lot of those data are just not available on the scale and over the time period at which we were looking, particularly for beluga whales, right? So there are satellites that detect things like phytoplankton or indirectly measure phytoplankton, but those don't necessarily go back to the same time periods that we were looking with our whales. So satellites might be the most sort of expansive or general area to cover a general area, but then when you look at things like shipboard surveys to measure those sorts of things, those are very localized and short-term and probably not occurring multiple times over a long period of time, particularly in the Arctic, although it is getting better. Yeah. Mm-hmm.
They might be less localized and short-term than people realize. There's, we get most of our food and everything by container ship.
Mm-hmm.
So there are 60,000 container ships in the world. The largest 10 of those 60,000, they use bunker oil. So they pollute more, the largest 10 of 60,000, than all of the cars in the world.
Mm-hmm.
And most of these are at sea, so that has to have an effect.
Mm. So
By far, the pollution of the earth happens at sea. Now, transportation doesn't, industry and whatever produce a lot, but there's a lot more pollution at sea than people realize. That's mixing, and a lot of these are migratory, and so I'd like to see a correlation between how much pollution is happening at sea that's affecting these animals, and if they're affected, then so are we.
Right. Well, so in the Arctic, there's not a lot of vessels yet, and so that is a concern, though, in terms of oil and oil spills in the Arctic, and that was something we couldn't consider in our vulnerability assessment when we looked on this Pan-Arctic basis, because there's just not, that's typically a point source, whereas we were looking at vessels as sort of as a pernicious sort of broad scale effect rather than these point source effects. Yeah.
When you were talking about habitat selection in belugas, you mentioned that sea ice was important, but that proximity to hot spots was more important.
Mm-hmm. Yeah, so that.
What do you mean by that?
Yeah, great question. What did I mean by proximity to hotspots in terms of habitat selection? That I was referring to some of the oceanographic hotspots in the region. So there are areas where currents and hydrographic conditions, the oceanographic conditions concentrate prey, think in areas like Barrow Canyon, for example, in that region, if you're familiar with it. And so, so there were certain areas that really came up as these hotspots that were important we think, for prey, and have certain oceanographic conditions that affect habitat selection.
So one follow-up question, is that what you were referring to as optimal habitat?
So the optimal habitat was the area that was predicted to be highest probability of use. So like, those were the red spots in the maps. Yeah. Yeah. Mm-hmm.
How do you tag them, and do you tag all of the mammals the same?
No, so different Arctic marine mammals and marine mammals in general are tagged in very different ways. Belugas are quite unique in that you can capture them and you can bring them into the nearshore environment. So there's a rope that goes around their tail. We put a hoop net over their head, and that subdues them really quickly. They're pointed sort of out to shore, so their tail is on shore, or not on shore, but close to shore, and their head's pointed out to sea. And then that tag gets attached to their dorsal ridge. And so other tags might be applied from a boat using something like a crossbow, and there's a little barb that sticks into the blubber of the whales, but that is quite different for belugas, at least in these cases, yeah.
If you had a lot of money, what would you research?
Oh. I think one of the things that's really interesting in the Arctic right now is that there are a lot of different things that are at play. So right now, the ocean is really incredibly warm, maybe unprecedentedly warm in the Chukchi and Chukchi and the southern Chukchi and the northern Bering Sea, sea ice broke up really early. We had unprecedentedly early sea ice breakup. And there's ships coming through, and there's all of these other human activities, and prey might be moving. And so I think one of the challenges for scientists right now, and certainly one of the things that I'm challenged by, is how do we disentangle all of these different factors that could be at play, and really start to understand what's pulling the levers in terms of responses and what it means in the future for these species and populations.
Is there a forum for you to discuss this among your fellow scientists instead of?
Oh, sure. Yeah, it's definitely a topic of consideration. Yeah. Oh boy. Okay.
We're going to be, we're visiting. From the state of Washington. Driving up, we noticed, car cross area, White Horse, there are a lot of sand dunes. Definitely, all this area was underwater. It was beach sand. At one point in time, it says there were probably a lot less ice and a lot more water. And then, 10,000 years ago, we had a lot more ice because there was the land bridge. So I assume whatever animal, in your migratory studies, you say, as the ice forms, the whales move.
Right.
So I assume they had to get out before the land bridge closed the city, otherwise they didn't make it.
Yeah, no. So you're getting a little bit outside of my realm of expertise, but yeah, no. So these are, belugas have been around for millennia, and so yes, they've adapted to changing conditions in the past, and I think that's kind of one of the unique or interesting things about a lot of these species is that they have weathered through variable conditions, and the Arctic is a dynamic place in general, and so there is some flexibility, plasticity in their behaviors and movements and habitat use that should be expected, I think. Yeah.
Were there times in our geologic history when climate was such that it affected the loss of sea ice to the extent that we're seeing now, or may anticipate seeing, and Arctic marine mammals were challenged by those conditions, just as they may be challenged now or in the future?
So there have been times in the past where there have been low sea ice conditions, but the rate at which this has changed in the recent decades is unprecedented. And the degree to which it has changed in certain regions is also, I think, unprecedented. So again, you're getting a little bit outside my expertise, but I do think that acknowledging the rate of change and how that has created very dynamic and variable conditions that haven't been seen before, and that all of these wildlife species and humans are having to adapt to is one of the things that we really need to be thinking about and paying attention to.
Since there's so much large vessel traffic on the Northern Sea Route, has any data become available from Russia? Or are they kind of close?
Well, you may recall that one of our areas of high uncertainty was the Russian Arctic. So it remains to be an area there. Just even getting the data sets that we did get in terms of the numbers of vessels moving through these regions, that was freely available from the Russian government and online. But yeah, so Russia does put different restrictions on vessels moving through these regions, and primarily they have been commercial vessels. So as I noted, I think on that slide, in the Northwest Passage, primarily the vessels that have moved through the Northwest Passage region are private vessels, so sailing ships and that sort of thing. And you're not seeing any of those because it's regulated through the Northern Sea Route.
But what I meant is, have they done similar studies on populations of sea mammals?
Yeah, I mean, there's some research that's being done for sure, and sometimes that work gets published in Russian journals that are in Russian, and so it's not as accessible to researchers elsewhere. And there is also still the need for more research. Yeah. Hey, Donna.
This is sort of an addendum. You
you've been talking about two very large populations, one of which is in Alaska. I think for the folks here, it's very depressing what's happening to the more southerly populations. The Bristol Bay population is now down to 278 or so, still declining. Bristol Bay, the most active fishery in Alaska, is reasonably healthy but small. The Yukon Kuskokwim, the Kuskokwim Bay, Kuskokwim River population was interesting. That became extinct by the 1930s. Kotzebue Sound is gone. So when I listen to the discussions here about such huge population sizes, it's interesting, and there's a lot of opportunity, but belugas are faring very poorly elsewhere.
Yeah, and so this is Dr. John Burns, who has been doing research in Alaska for decades and has certainly served as one of my mentors, and so I think he has a lot of wisdom to share. And I think it's a good point, John, that that particularly, I think if you look across the subarctic, not just in Alaska, you see belugas doing really differently. And subarctic belugas in general, so the Bristol Bay population, the Cook Inlet population, the St. Lawrence Seaway population, those populations are not as migratory as these Arctic populations. And so they have more localized behaviors and perhaps more specialized habitat or even prey species. And so it is a really interesting contrast to some of these more migratory populations, such as what I've been talking about today. Thanks for that comment. Yeah.
Well, I think we've just about run out of questions, so we're going to say thank you to everyone. Thank you so much.
Thank you.